Hey guys, welcome to night 8 of Lambda School's mini bootcamp. It is our very final night of learning some front-end JavaScript, so thank you all for being here. My name is Deandra Ryan Moss. I'm an instructor at Lambda School, and I am teaching you guys live tonight from Bisbee, Arizona. So let's do it. The obligatory Lambda spiel, here it comes. So Lambda School is a 6-month immersive for computer science and web development. We teach you cool things like how to build web apps and other stuff. But seriously, we go through all the tools you need for full stack web development. So that's front-end JavaScript, back-end JavaScript, more in-depth HTML and CSS, frameworks necessary like React, Bootstrap. We also cover some CS topics that are a little divorced just from the web development world. We talk about C, Python, algorithms. You come out of it just with a really broad, expansive knowledge of what is going on in the programming world. So it's really cool. It's all online, so there's a lot of different ways that a lot of different things you might do during your day. So there are, of course, live instruction. There's going to be group work, Q&As, time for you to just work on homework and projects independently. It's pretty cool, and it is all online. It's full-time, and you do not have to pay anything up front. So instead of forking up a bunch of cash and then hoping for the best, like I had to do when I went through boot camp, you can instead actually pay $0 upfront and sign an income share agreement, which means that once you get hired, you'll start paying Lambda School back over your first year or your first 2 years of being hired. So you paying your tuition is contingent on you finding a job in the field, paying $50K or over. So that's pretty cool, because if you don't find the job for some reason, you don't actually have to pay your tuition. So that's kind of nice. But the good thing is you're probably going to find a job, because we teach you a lot of cool stuff and we have hiring resources, and it's really set up to send you guys out into the world with the skills you need. So that's Lambda School. I know a lot of you guys are bound towards the main curriculum after that, so I'm really excited for that. And I will still be here in Slack. You're welcome to reach out and say hi. Let me know how you're doing. If you haven't applied yet, talk to Karen Zachary. She just posted in Slack, so she should be really easy to find. So talk to her on Slack. She's a great resource for either actually starting that process or answering any questions you might have. So tonight is the final night of the mini boot camp. On one hand, we have covered so much material in 2 weeks, like a lot of material in 2 weeks. On the other hand, we've really only scratched the surface. So I think that you guys have some really core building blocks in place, but there's so much fun, cool stuff left to learn as well. So it's cool. It's an exciting part of the journey. I know that when you're at this stage, it can be easy to feel like, oh, I'm just, I wish I knew more. I wish I knew this. But I really think that this is really the exciting time. And like, I look back really fondly on my memories of being in boot camp, though it was stressful as all can be while I was there. So just take a minute to take some perspective and like be excited for yourself for taking a risk on yourself and shifting yourself towards something cool that probably will change your life for the better. So yeah, I just wanted to say that. Anyways, enough of me getting sentimental. Let's actually learn some JavaScript today. So we have one more topic left. It's called Callback Functions. So another function-oriented night. Callbacks are really great. They are something that makes JavaScript really special, and they are like a key component to the actual web development side of JavaScript. So let me go ahead and share my screen, and we can talk a little bit about, do a little review of functions, and then really get into what callback functions are. Okay, here we go. All right, so callback functions. There we go. So for starters, let's do a little review of functions, because in order to understand callback functions, we want to make sure that we're feeling really solid on our basics of functions. So, oops, cap lock. Okay, so let's start by creating a function. We'll call this one add3. It's a function, and this is going to take in a number as a parameter, and we will just return that number plus 3. All right, let's do another function called call this second character or second char. This is going to take in a string. And what we're going to do is actually, I don't know if you guys have seen this yet, but you can, just like an array, you can actually grab individual characters off of a string with that same bracket notation. So, so this will pull the second character off, and then we'll just return that. So let's play with both of these, make sure they work. Add 3. And we got out 7. That seems good. If I do -2, -2. Also seems to work if we do second char of night 8, we get out an I. So it seems like these are working pretty well. Cool. So let's break down what's going on with each of these functions. First, we'll talk about what they have in common. In both cases, we've used the keyword function, and in both cases, we've specified what our function is going to be called, though in slightly different syntactic ways. In both cases, we defined our parameter. Up here, I've defined x to indicate that my parameter is a number. Down here, I've done str to indicate that we're probably expecting a string. Inside our curly brackets, or our function scope, we have all the logic. So any sort of behind-the-scenes function logic goes in between the curly brackets. And then in both cases, we've ended with a return statement, telling the function, this is the value I want to spit back out. As far as calling the functions, we see we just need to use the function name with the parentheses that indicates function call, and then we pass in our argument of night 8. As a little reminder, an argument is a specific value that we put in a specific function call, such as night 8, which we put on to this call on line 10. Whereas a parameter is more like a generally, this is what the function expects. So in general, it expects a string. In this case, we've passed in this specific string. So arguments and parameters, going to talk a lot more about them tonight. Up here, we can see that the argument is a number. And in the example of the function call that I had before, the parameter, or sorry, the argument was -2. So parameter x, argument -2. So those are arguments and parameters. As far as return values go, we can always tell a return value because we have to actually type out the word return. Down here on the function call line, we can see there's a return value because the function evaluates to this value of 1. So if we call the function in Replit on the last line, we can see the return value appear in green. A nice little trick we can do in Replit to check if a function has a return value or not. Syntactically, these two ways of declaring functions are slightly different. Just from a pure syntax viewpoint, we can see that up here, I've actually used const to name the function, to create a variable in memory, and then I've used an equal sign to assign in an anonymous function. So when we have a function floating on its own like this, just with the function keyword and no name, that's called an anonymous function. We will see a lot more of those tonight. So anonymous function, once again, that's a function without a name. I could just have it on its own here, but then nothing would happen with it, and that wouldn't be very exciting. So far, the only time we've really seen these anonymous functions are when we create them and then store them into a variable name. I guess we've also seen them in the case of objects. So we might have an object with a key called add3, and then we have so this is another example of where we might see an anonymous function is we might see inside of an object a key set equal to an anonymous function. So there you go. So back to how the code was before. Yeah, so that's one way to declare a function. And as we know, this is not hoisted. So if I call add3 below, I'm totally fine. But if I call add3 up here, I'm going to get an error, add3 is not a function. So when I say hoisted, it means that this whole bit of code doesn't execute until we actually hit those lines. This one is hoisted. So when we don't actually have the anonymous function, when we just name the function from the get-go, we don't have to use const or let. We've just stored this thing without having to actually declare a variable. And what that means, among other things, is that it's going to be hoisted. So if I call second char at the top, it works anyways. So little subtle difference between the use cases of these. I would say the big takeaway is, apart from the fact that this style of function declaration is hoisted, is that to remember that when we declare a variable, we're storing in something called an anonymous function, which is going to come up again many times tonight. So that's a little function review. Really, the most important things we're thinking about when we create a function are these ideas of input and output. So we want to make sure we know what our parameters are and what our return value is. And we are going to want to keep meticulously close tabs on what those are tonight. So we're going to really be looking at that in detail. Okay, so before we really get into callbacks, I want to talk about something that's really cool about functions in JavaScript. And we've seen a little of this already, which is this idea of that functions work like any other type of variable. So I'm just going to put this at the top. Functions work like, I'll really say, any other data type. And so for starters, we can see that that's true because we can store a function in a variable just like this, right? So the other thing we can do is, if I want, I could do +3 and store in the value of add3. So I've just gone ahead and declared a new function and taken this old function and used it to just pass that function in. So now +3 is the same thing as add3. So maybe not super useful because now we just have two copies of the exact same function, but just a little viewport into what's going on behind the scenes, which is that we can pass around functions exactly how we want. So we could even do a similar thing with something like console log. So keep in mind, console log without the parentheses is a function. So if I want to save the function somewhere else, I wouldn't call it, I just write out the name of it. So now if I don't want to type out console log every time, I've gone ahead and stored that logic of console log inside of a new variable called log. So log will work exactly the same as console log. We could do that with math.random too. As a reminder, this won't work if I call the function. If I called math.random, then random is just some random number. But if I do it without the parentheses, now I've actually taken the logic, the random number generator, and saved it in here. So now I can call this thing and create new random numbers every single time I run the code. Cool. So that is a little more insight into some of the cool stuff we can do. So check out something else we can do. Let's say we have, I'm going to create a function called identity. This thing is super boring. We pass in some sort of value, and then we just return it back out. So the most boring function in the world, except maybe the blank function. Okay, so as we know that we can call identity with, if we put a number in, it'll return that number back out. If we put a string in, even if we put an array inside here, turns the array out. But check it out. We could also pass in, let's pass in random. And it returns back out a function. We could even pass in, okay, this is a little crazy. We could pass identity into identity, and it still returns out a function. So what we've just gathered here is that functions can be stored in variables, as we knew. They can be passed around to different variables. They can be passed into functions, and they can be passed back out as return values. I could even create a function, another really boring function called return log. It literally just returns out the console.log function. So this thing just returns out a new console log function. So now if I wanted to create, this is like a really convoluted way to do this, by the way. So now if I did that and actually tried logging something, it would work. Okay, so I've just like basically in the most weird convoluted way created a new version of console log. This is not good code. I've basically done nothing with like several lines. But the takeaway here is that functions are valid return values. That's really the only important takeaway here, is that we're allowed to return functions. We're allowed to pass functions in and return them. Returning functions turns out super useful, but we're not going to really talk about it too much tonight. But this idea of actually passing functions into other functions is exactly what we're talking about tonight. So a callback function, callback, is a function that is passed as an argument into another function. So we're talking all about functions being passed into functions. And that's why this lesson can get a little confusing, is because it's like, wait, are we talking about the past function or the bigger function? So I'm going to try to be very careful with my terminology and break things out into detail, because this is one of those conceptual, like tie your brain in a knot type topics, as if you haven't had enough of that already. So let's talk about callbacks. Okay, cool. So I wanted to define callback. Let me just do a really, really simple function. So if we have something called higher order, and this thing takes in a callback. So notice that my parameter, wait, what have I done? Yes. Okay, so my parameter here is a callback function. So we're expecting a function to be passed in. So all we're going to do is call the callback. So higher order is a function that takes in another function and then just calls it. Once again, from a usefulness perspective, this is kind of just a waste of time, but it's a good simple example to get us familiar with these ideas. So let's see how it works. So if I take higher order and I pass in, let's say, math.random, oh wait, I didn't return it. Let's have it console log the result of the callback being called. Okay, actually, let's do this. Sorry, guys. Okay, result. So we're going to call the callback function, and then we're going to console log the result. Okay. So now when I pass math.random in as a method, or sorry, as an argument into higher order, we call it, we store the result, and then we log the result. So each time I call this, I log the result of math.random. But if I wanted to pass something else in, like I'm trying to think of another function that doesn't take in any arguments. Yeah, I can't think of anything right now that wouldn't involve some complexity. So we'll just do it with this one example. Though we could make it a little more complicated. We could pass in an argument, a second argument, and pass that into here. So now if we did math.round and we passed in our 1.7, so what we're doing is a little mind-boggling, I know, but for now, let's just think about it this way. We have passed in a function into another function. I'm going to go ahead and simplify this again. Okay. Cool. So let's break this down in detail. So we know what a callback is. A callback is the actual function that is passed in to another function. But let's define higher order, because that's the other piece of this puzzle. So a higher order function is a function that takes a callback as a parameter. Okay, so callback is the one that actually gets passed in. Higher order is the one that has the callback as the parameter. So in every case here, we're going to have to think about two functions at once. The higher order one, which takes in the callback, and then the callback that's actually being used somewhere inside of the higher order function. So as we see more examples of this, I think it's going to start to make a bit more sense. But first, I just want to talk for just a minute about why we would do this. What are some important use cases for this? And I mentioned briefly in the intro that it's really important to web development. So let me explain why. Using callback functions allows for something called asynchronous programming. So JavaScript is an asynchronous language, and without getting into too much details, essentially, it's just a little trick that allows it to run really fast. So the way that JavaScript is sometimes run is asynchronously, which means that things aren't necessarily executed right away, and that allows the code to actually run faster, which is really important for web development because load time is critical. In this modern age of computers, you will lose potential visitors to your page, your app so quickly if it doesn't load. So behind the scenes, we do this asynchronous thing to make it go faster. And it turns out that callback functions aren't always used because there are ways around them, but callback functions are kind of this tool that was created to help facilitate this asynchronous style. So there's a lot in there that I just kind of threw out without fully explaining. It will all make sense once you start getting into this stuff more deeply. It'll all make sense in the main curriculum. For now, I just want to say, hey, callbacks are important for learning JavaScript, and it has to do with load time. So another reason that we love callback functions is there's a style of programming called functional programming. And this is, once again, another big topic that I would love to talk to you guys about because I think functional programming is the bomb. So look it up if you have a minute. It's pretty great. But in order to functionally program, you need to be able to work with callbacks for sure. So once again, that's like this giant door that I just opened a little bit and then closed. But I just want to make you aware of it, that there is something called functional programming that's really cool, and you should check it out. It's not like a language. It's just a technique you can apply to how you write your JavaScript or other languages. And then the last thing I want to mention is just dry code. We've been talking about this all week. Don't repeat yourself, dry code. So we'll see as we go through some examples about why this gives us an extra tool that'll help us write drier code. So without any more convincing, hopefully you guys feel like, yes, this is a worthwhile skill to learn. So let me show you a couple examples of built-in higher order functions that make life easier. So there are 3 array methods I want to share with you that are all higher order functions. So let's start by creating an array. Let's do, oh man, what do I want to do? I always feel like I need to come up with something creative for my arrays. We'll just do animals again. That was fun. Okay. So we have by the way, a coati is like a South American cousin to a raccoon, and they're super cute and also worth Googling. Okay, so here's my weird collection of animals. Let's go ahead and play with some array methods. The first one I want to show you is something called for each. So if we do animals.forEach, we can actually loop through the animals. So we saw for loops we saw for loops last week, right? Yes. We saw for loops last week, and then on Tuesday, we saw how they apply to arrays. And I think I mentioned that there is a better way to loop through arrays, and now we're learning it. It's called the for each loop. So we don't have to ever write a for loop. We don't have to write out the syntax at all. What we can do instead is just plop an anonymous function in here. So what I'm going to do is introduce these array methods pretty quickly, And then we'll go back and break them down in detail. So don't panic if you feel like you don't get it. I just want to introduce you to what each of these does, and then we'll talk about how to use them in a little more detail. So for each, if it takes enough function. So actually, let's just start by writing out a function. So I'm just going to do log. So what this function will do is it will take in an individual animal, and it's going to log the animal. So console.log animal. Cool. So what we've done is we've created a callback function. So this would be considered the callback because we are going to pass log into for each. So we see that this is just a method, just like any other array method, except that it expects a function. So we would say that for each is a higher order array method because it expects another function as its argument. So I passed in log as the argument, and look at that. We were able to log all of them. So that's what for each does. It's essentially a sleek, higher order way for us to loop through an array more easily. So what for each does is it just loops through and executes some bit of logic individually on each item in here. So that is for each for you. And then let's talk about map. The next thing I want to do is map. So map is also a higher order function. Let me get rid of this callback. What map does is it actually, instead of just executing some logic on each of these, it actually creates a whole new array. So for each doesn't return anything, it just kind of executes some logic, whereas map actually returns out a whole new mapped array. So let's say we wanted to capitalize all of these. We could do, if I can spell capitalize, probably right, maybe right. Okay, so once again, it'll take in an animal, and we're just going to return animal dot to uppercase. All right, so what we've done is we've created a callback, which just takes an animal, an individual animal, and returns the uppercase version of it. So what happens when I put that in here? Well, now we get out a brand new array with a capitalized version of everything. So once again, map actually creates an entirely new array where every individual item has been augmented in some way. And yeah, so that's map, another higher order function. The last one I'm going to really breeze over. It's not something we're going to break down in detail in this class, but it is asked on the homework as the stretch questions. So the last one is reduce. At the very least, I want you to know how reduce works, but you don't have to be a reduce master, and we won't really break it down in detail tonight. So whereas map actually took the array and created a new array, reduce will reduce an array down to the very down to one single item. So let's say we wanted to find the longest item in the array. We could create a callback called check length. And so we'll compare the longest string versus the animal, and we'll say dot length is greater than our animal dot length. I know I'm totally breezing through this. I mostly just want to show you just what it does. So don't worry too much about everything I just put in there. I know I'm like totally going all programmer crazy without explaining myself. Okay, so not worrying too much about the logic inside of here. We have a callback that just compares the length of two things. So when I pass that into reduce, instead of returning out an entire array, it now just returns out a single value. In this case, the value that has the longest value here. So we went and checked the character length on all of these, and then we were able to return the longest one. So once again, reduce, wanted to introduce it. We'll kind of ignore it for the rest of the night, but the takeaway here is that reduce takes an array, a collection, and reduces it down to a single item. So these are all super useful. Map and reduce especially so. I did a lot of data aggregation in my old job, and when you're working with data, being able to do this mapping and reducing is like ace. It's so critical. So really useful tools that are built in for you guys. Let's go now and break down for each and map. So we'll break each of these down, both with the intention of getting you guys to be masters of these array methods, but also with the intention of getting you guys a little more familiar with thinking about callbacks versus higher order functions. So, okay, so we have our animals array. Let me create a numbers array too, because that's always nice to have on hand. Okay, cool. So let's talk about for each. Once again, for each goes through and just executes some bit of logic on each individual item. So let's talk about writing the callback. So when we're writing a callback function for each, it has to be of a really specific format. So let's say that we wanted to do something like log negative, or let's just do log, that same example I did before. So I'm going to write this out, and then I want to draw your attention to a couple things. So console.log animal. Okay, so this is our callback function. So the most important thing about the for each callback, two important things. One is that it takes in one parameter, and that parameter should be an individual item on the list. So notice that this parameter in the callback is not an array. We're not ever working with the collection as a whole. We're only working with an individual item. So in general, you might think of this as being item. Because we know we're working with animals specifically, we could go ahead and call it animal. So we know that the input, the argument passed into this log function is going to be each individual member of our animal array. So once again, think about this as being one unit, not the collection, one unit. Okay, so inside our function scope, for a for each callback, we do some sort of logic on our animal friends, and we don't return anything. So no return value. So this is the format of every single callback function for each. There admittedly are some optional parameters, but we're not going to talk about them today. You're welcome to look those up if you want. But this is the basics of what you need to know to write a for each callback. It takes in one item from the array, we execute some sort of logic, and then we don't need to return anything. So if we went ahead and called it, let's dot for each, and then remember that we pass in the actual function. So we don't pass in a function call. That won't work for us. We want to pass in the function itself. Okay. So now it works. And notice once again that they're all logged individually. We never see the whole array logged. And that's because this function is working on individual items. So if you guys want a little insight into what's going on behind the scenes, it turns out that log is going to be called 5 different times. There is a loop going on behind the scenes, but you never have to actually write that loop yourself. So this is being run through log, then this is being run through log, then that one, then that one, then that one. So this callback will actually be called 5 times, but we don't have to call it once. We just have to pass it in, and for each, we'll do all the heavy lifting for us. So for each callback, one parameter, single array item, no return value. Okay, so that's the callback. Now let's think about the higher order function. So that's the for each function itself is the higher order function. Notice that this also has one parameter, which is a callback. So the one parameter here is the function itself. And we can see that this one also has no return value. We can tell that there's no return value because when we run it in green, we see undefined, which means that this line of code isn't returning anything. So this is important. We have to be able to specify which function is the higher order function, what type of parameter does it expect, and does it return anything? And then we have to take a step back and say, okay, what's the callback function? What types of parameters does it have, and does it return anything? And it turns out that for each, any callback that's going to work is going to be of this format. So let's think about logging a negative value for our numbers. So if we wanted to log some negative values, we would want to call numbers.forEach. And then we want to pass something into forEach that specifies log a negative number. So we could write out a whole log negative function, but we can also pass in an anonymous function. So let me show you both ways. So let's start with a function called log negative. We know this expects an individual number, so not a collection of numbers, but just one number, because we'll work one number at a time as we go through our array. And then we'll just console log negative x. So if I pass in log negative, of course, we still get our animals logged, but now we see that our numbers array, as a reminder, there it is, was the negative versions of everything was logged. So notice that there are some similarities, right? Log negative also takes in one unit, one item in an array, and does some sort of logic on it, and then there's no return value. So the last thing I want to show is that you don't even actually have to name your callback if you don't want. Sometimes it's more convenient to plop it directly in. So yeah, so this syntax looks weird when you're only seeing it for the first time, but I've just taken the anonymous function and passed it directly into forEach. So if we think we might use log negative again somewhere else in our code, it's worthwhile to write it out and save it into a variable like this. But if we know this is the only time we want our logic, sometimes it's just nice to be able to put an anonymous function directly in. So I mentioned anonymous functions would resurface. They're really common when you're using higher order functions because it's convenient to just plop them directly in like that. So notice that when I run the code, it works exactly the same. It was able to take this anonymous function and still apply it to forEach as expected. So that is our a little forEach broken down in much more excruciating detail. But hopefully you guys are starting to get a hang of like, okay, this is the higher order function, and this, either this anonymous function or this named function or this one, all could be the callback. So there can be a bunch of different potential callbacks you pass into a higher order function. They just all have to be of the same form. Notice that if I created a function like add, it takes in two numbers and returns a result. So this is not of that correct format, right? It has two arguments and it has a return value. So what happens when I pass add into forEach? Well, nothing happens. I mean, something's happening behind the scenes, but nothing interesting happens, right? Because we kind of messed up. Like, okay, so what if we got rid of the return statement and just console logged x plus y? So now something really weird is happening, right? It would be fun to talk about why this occurred, but that might be outside of the scope of this conversation. So some weird stuff just happened there. So this is not behaving as we expect, and that is largely because we are passing in something that does not work as a callback for forEach. It just has the wrong format. So you have to be really aware of that. Okay, let's go ahead and move on to map. I really like map. I find map to be extremely useful. So let's do some mapping. We'll start with that exact same example of capitalizing. So I created, means I'll have to spell capitalize again. capitalize. Okay. So this is going to take in an animal and return animal dot, oh, not return. Yes, return. To uppercase. We can hopefully already see that this is a little different. So this is our map callback. It's a little different than our for each callback. We see that there's one parameter. This part is the same. There's one parameter, which is an item in the array. Now we have a return value, which is a mapped version of that item. So we take in, once again, an individual item in the array, and then we do something to it, and then we return it. So we see that the map callbacks already look slightly different than the for each callbacks. So let's go ahead and actually use it. So down here we have our higher order function. And let's write it out. So animals dot map, and then we're of course going to pass in capitalize. So we see that our higher order function has one parameter, which is a callback, and it has to be a callback of this format. And then a return value is going to be an entire mapped array. So the callback function returns a mapped item, whereas the higher order function returns the entire mapped array. And sure enough, we can see that. We can see up here that, that when we run this final line of code, an entire mapped array pops out. And so yes, there was some looping going on behind the scenes, but notice that we didn't have to ever call capitalize. We don't call it, we just pass it in. And behind the scenes, it will be called 5 different times on each of these items. So let's try mapping our numbers, and we'll practice that anonymous function right now. So if we do numbers.map, let's say we just wanted to add subtract 1. Let's do that. So once again, I just took a function and plopped it inside of the map. So as we know, this has to take in one parameter, an item. So we know that's an individual number. And then we want to return a mapped version of that number. So I'm going to do x minus 1. So this is the callback. And once again, it's of the same format. One parameter, a single number, one return value, which is a mapped version of that number. Now, if we consider the entire higher order function, we see that an entire mapped array is returned. And once again, if we did something else in here, like x and y, and returned x plus y, some weird stuff happens, right? So that's why we have to be careful to make sure that we are actually putting in something of the correct format in here, because otherwise weird stuff will happen. So there you have it. That is how we use map. So the last thing I wanted to talk to you about is writing our own higher order functions. So here we have, we've used map and for each, which are built in, right? They're methods. So they're actually built in higher order functions. And they're super useful. But often we might want to write our own higher order function. So the first thing I'm going to do, the first example I'm going to show you is we're actually going to create our own version of map. So I'm going to call it map. And so what this thing is going to do, it's going to work pretty much just like the built-in map. So it's going to take in an array and a callback. And by the way, by convention, callbacks, if you have a parameter, you usually actually call it callback or CB. It just helps clarify things to your fellow developers. Okay, so this map function, actually, sorry, just kidding. We're going to do an each function because that's a lot easier. So my bad, false advertising. So let's create our own custom version of for each. So in this case, we have to actually pass in the array, or even, sorry, I keep changing my mind, guys. Let's do, yeah, let's do it this way. So we pass in the array, and then we pass in a callback. And remember, the callback is the thing that we want to execute on every item in the array. So now that we're actually writing for each, we have to do all the stuff behind the scenes that was done for us before. So if we want to execute a callback on every item in the array, we probably need a loop. So we could do 0, I less than array.length plus, cool. And then within our for loop, we would want to take an individual item. So I'll just do array at I is going to be an individual item from our array. And then we want to pass it into the callback. So remember before that we never had to call the callback. It was done for us. But now that we're writing the higher order function, we have to call it. So when we write the higher order function, somewhere in it, we probably should call our callback. So what I've done is I've actually called the callback and passed in an array item. So I have done everything that was happening behind the scenes for us. I've written it out explicitly. So let's go ahead and try to run our own version of for each. So we'll pass in numbers, and we'll pass in. So we know this is our callback, so it takes in an individual number. And let's just do that log negative logic again. So I'm saying I'm passing in the array, which we now have to do because it's not actually a method, and then passing in this function. So, and it seems to work. So this gives us some insight into what's happening behind the scenes for each. We actually have to, behind the scenes, there is a loop powering for each, and we do have to call the callback, however many times on every item. But because we don't want to have to do this logic again and again, we can just use the built-in for each to actually take care of a lot of the legwork for us. But this gave us some insight into how to write a higher order function. I think the biggest thing to keep in mind is that your callback actually needs to be called at some point, or else it's not going to work as expected. So let me do one more example, and then I will open up the floor to questions, and then we are done. So done. Okay, sorry. I feel like I'm a little spazzy tonight. It's probably because I ate chocolate right before class. Okay, so let's go ahead and write our own, just a very different non-array related higher order function. So I'm going to, first of all, let's create some feedback functions. So we have a function that complements. Let's go ahead and create an insult function. I apologize to anyone in the audience with hairy back. That's not fair. I'm sorry. That is totally biased against people with hairy backs. Let's do stinky breath. We all deal with that. Okay. And then let's just do let's leave it there for now. So I've just created these two functions called complement and insult, and they both just log some stuff. The first one logs a complement. The second one logs an insult. So these would be our callback functions laying in wait. So let me create a higher order function that we might use these with. I'm going to call this give feedback. So give feedback is going to take in some sort of callback function where we give the feedback. So whenever we give feedback, we first want to say like, hey, there's something I need to tell you. And then we want to actually give the feedback. So as I said before, One of the critical pieces when we're actually writing a higher order function, we first of all need to specify that a callback is coming in. And second of all, we need to make sure that we call the callback. So every time we run give feedback, it's always going to log this first line, but then it'll log a different bit of feedback depending on how we call it. So if I call give feedback and pass in complement, then it does the little first log and then it compliments us. Now if I do insult, it insults. So in this way, I can actually completely change what feedback I'm giving by just changing one variable name. So this goes back to this idea of being dry. If I had to write out a bunch of different functions that all had the same line at the top, that wouldn't be very dry. I'd be repeating myself. But in this way, I can dynamically change the feedback I'm giving you with just one variable change. And if I even wanted to create another one, like a neutral comment, I could plop it directly in using an anonymous function. Say something like, so there we go. That's just a little non-array related example of how we might use callbacks. And it's really nice too because these insult and complement functions exist all on their own. So maybe there's somewhere else in our code base where we might want to use them, as well as just passing them into our give feedback function. So that's pretty much it for you guys. We're actually done before 6 o'clock, which is exciting. Let me just go over a little bit of what we've talked about tonight, and then I will open up the floors to questions. So yeah, so what we talked about tonight was callback functions. And callback functions are when we take a function and pass them into another function. So when we're talking about callbacks, we really need to differentiate between the callback and the higher order. So for example, with these callbacks, we can see that there are no parameters, no return values. So that makes them pretty simple, but we know that this higher order function is expecting a function of this form. So if I, once again, did like an add function, it wouldn't work very well. Over here in our higher order function, we see that it has one parameter, which is the callback, and then no return value. So when we're thinking about this question of input and output, which we should always ask that question when we work with a function, now we have to ask the question twice for a higher order function and for the callback itself. And there's an entire assignment tonight on breaking down the difference between the two. So you guys will have lots of practice yourselves to think about which is the higher order, which are the callbacks, what type of parameters and return values do each of them have. So callback functions, super important. They open up a whole world of built-in JavaScript array functions that you can use, like for each and map and reduce, as well as it gives you a new tool for writing your own code. So I'm going to first open up the floor to questions on everything we learned tonight. Then I want to say just a couple things to tie everything back together, and then we will be done. So it has been really great having you guys ask all the questions. I left plenty of time for questions. This is your last chance. So yeah, go ahead, hit me in Slack. What have you guys got? I do see, I will go ahead and just say, I know a couple people are talking in Slack about like what next. And the two obvious courses are, you know, if you've for some reason decided you don't want to do Lambda School, which is sad, then this is it. And if you are interested in Lambda School, reach out to Karen and start the process of applying. I will say that I know I've talked to a lot of students who go through the bootcamp and this mini bootcamp and really like it and are really interested, but feel like the pace is a little fast. So if you want to take time to finish the homework afterwards, if you want to come back and rewatch the videos or even sit in on the next version of this, that's not that uncommon and totally fine. And take the time you need to really master the fundamentals. It'll help you a lot down the road. Okay, I do see, actually, I see a lurking question from about 10 minutes ago that I had missed. So the question is about map. It says, can you grab specific items in the array with map? Like, you know, like we've seen before. So as we know, when we have an array, I'll just do numbers, even though it's not as fun as animals. If we wanted to say grab the second item, we could of course do numbers at index 1. That'll give us the second item. But if we wanted to grab a specific item using map, it wouldn't really work. So map is specifically designed to return an array. So no matter what callback function you put into numbers.map, you're going to get back out an array. So there's really, it really wouldn't work that way. So it's really designed to create a new array rather than an individual item. If you want to turn an array into an individual item, reduce is the way to go. But honestly, if you know that you specifically want the second item, just do this. It works. It's simple. Don't make life more complicated than you need to. So if you know that you definitely want the second item, then just use bracket notation. But if you were trying to do something more complicated, like find the largest item in the array or the smallest item or the item that's closest to 7 or something like that, then you would probably use something like reduce, and you could write in some more complicated logic to try and find a value in here that matches some specific criteria without knowing where it is. Okay, I see a couple questions. Awesome. So the first one is, can we go over the reduce example again? Yes, let me go over that. And in fact, I'll use it to, let's go ahead and find, what do I want to do? Yeah, let's find the largest item. That's a pretty simple reduce one. So numbers.reduce. Okay, so I am going to break down reduce in slightly more detail now, just because you guys asked about it. So the reduce callback function is a little weird. So if we were trying to find the largest number, the first parameter in our callback is going to be basically the largest so far. So this is the largest one that we found to date, whereas the next parameter would be the current number. So basically, each time that this callback function is run, we're comparing two numbers. We're comparing the largest one we found so far with the current number that we're on. And so what we want to do is return the largest of the two. So if the largest so far is greater than the current number, then we just return that. Otherwise, we return the current number. So let's check it out. Bam. Let me throw some more things in here. Bam, still works. So I will take a minute to break down in a little more detail what's happening here. So this callback is going to run, let's see, 1, 2, 3 times. So by default, it's going to assume that 5 is the largest so far, the first one. So for starters, we're going to compare the first two. So the first time it runs, callback runs first time. The first time it runs, we're going to compare 5 and 2. So I'll just do first callback. So we compare 5 and 2. So the largest so far by default is considered to be the first one. And then the current number, we just start with the second one. So we compare those and we return 5. So 5 is still going to be our largest so far. So the second time the callback runs, we're not actually comparing these two. We're comparing 1 with the largest we've seen so far. So largest so far is still going to be 5, and our current number is now going to be 1. So we'll compare these, and 5 still wins. So the third callback will compare our current winner, which is still 5, to the current number, which is now 9. And in this comparison, 9 is actually going to win. So 9 is the value that is spit back out. So this still, even though I've broken it down in more detail, this is still a little bit of a rush through what's a pretty complicated thing. You don't have to understand what goes on behind the scenes, though I think it can be helpful. The most important piece is to think about comparing the largest so far, the smallest so far, or whatever the default so far is, to the current number. And then you return whichever one wins. And that's how you would reduce down an entire array to a single number. So that's a little more of a breakdown of how reduce works. I'm sure you can tell just from the example that it is a little trickier to master than map or for each. But I do invite you to play with it on the stretch questions on the homework tonight. Even if you don't totally get it, it's a fun little exercise. So, but start with map and for each. Like, start with the basics. You will get to reduce eventually. Okay, so the next question is asking if I have a favorite computer science book. Well, yes and no. Okay. So as far as an actual practical book, no, I actually hate reading books on programming. Like, if it's actually explaining how to program, hate that. Can't learn that way. Have to do it hands-on. But one of my favorite books of all time is called Gödel, Escher, Bach by Douglas Hofstadter. I'll put that up here. That's a mouthful. Actually, I'll just Google it. So this book, I read this book before I ever learned how to program, and I was actually learning how to program like by hand in my journal without even realizing that's what I was doing. This book, it's super long and it's super nerdy, and it's all about like math and recursion and all this crazy stuff, but it's also extremely funny and creative, and like I cannot recommend this book enough. It won't like teach you to code practically really much, but it'll teach you to think, and it'll teach you a lot of fun stuff. So yes, I will shout out this book, but it's maybe not what you were thinking of. It did, like, this was the book that inspired me to get a math degree, and so it was a really influential book. I probably wouldn't be here today if not for this book. So yeah, that's maybe not quite the answer you were looking for, but that is a book I love, and that definitely relates to programming. And then, okay, so another technical question, does map modify the original array? So no, it doesn't. It creates a brand new array. So let's look at that in practice. So if we have, and I'm going to create a new array called mapped numbers, and we'll do numbers.map, and let's multiply by 100 this time. Remember, the map function requires a return value. So I'll console log the original array and console log mapped numbers. Okay. So we see that our original array is as we had hoped, and our new array is mapped. So yes, mapped creates a brand new copy, so that we still have our original array, but we also have our mutated version. And notice that if I forget my return value, it's just full of undefined. So return, important in map. We don't need one in for each, but very important in map. All right, any other questions? No one else needs a book recommendation or to discuss my cat owning habits? I did see, for all of you guys invested in my porch cat adventure, I did see a pretty battered looking orange cat in front of my house the other day. So I think I have a contender. But anyways, all right, it looks like things are pretty quiet, which I'm guessing means you guys just want to get to your homework. All right, well, this is it. You guys have been really great. You've been really interactive on Slack, which is my favorite thing. So I'm going to miss you all, but I'm still in Slack. So once you move on to bigger and better things in the main curriculum, feel free to say hi. The homework is still a thing. There is the normal homework tonight, and there's a comprehensive thing you have to do too. Sorry, guys. And I will say it's really common that people aren't able to keep up with the homework. I know it's a lot to expect like 3 hours of attention, and I know the homework is hard because I wrote it and I'm kind of evil and I made it that way. So, so yeah, I understand that probably some of you, if not most of you, aren't where you want to be on the homework, and really don't worry about it. Take your time to do it. We'll still be available in the MBC After Hours channel to answer questions as we move along. You can also pop in and say hi on the next section. The next section, by the way, starts a week from Monday. So that's the simple math 11th, maybe. So a week from Monday, we start a new section. If anyone's interested in rewatching some of the videos, that's welcome too. But really, I would just overall say, like, I think the #1 thing I see in my students, and I remember doing myself when I was in boot camp, is just being like way more hard on myself than was necessary. So this is really tough stuff. So good on you guys for being here and sticking with it. Don't get too frazzled. It's like, it can be really frustrating right at the beginning when you don't know any syntax and you have to look up everything you do, but it gets super fun once you master some of the basics. So stick with it, ask questions in Slack, and thank you so much for being here and for sticking with 8 nights of me babbling about computer programming with you guys. And yes, okay, July 7th, I did do my simple math correctly. June, yes, I think June 11th is when our next section starts. I do not have a month off, sadly. That would be fun. Okay, so that's it. Gonna stop babbling, gonna say goodbye now. I'll be in Slack for a few more minutes tonight if you have any follow-up questions. And as always, just various people will be available if you need support. So, okay, that's it. Thank you so much. Have a good night. Bye, guys.